Let us have the technical program on prime number using while loop. So what is a prime number? Prime number is nothing but a number which is getting divisible by 1 and itself. So if I am having a number, let me say n equals to say 7. Now we know that 7 is a prime number. Now how to check this particular 7 is a prime number? So n percentile 1 is equals to 0. Can I check like this? No. 1 and itself? No. And what is happening? N percentile 7 is equals to 0. Can I check like this? No. We cannot check because we know that these values are dividing the n value, dividing this particular value called 7. Now how we need to check? Apart from these particular two values, we need to use something like the n value. Nothing but 7 has to be getting divisible by 2, followed by 3, followed by 4, followed by 5, followed by 6. 7, no, it is getting divided. Now what about 8? No, because we are going to get the decimal value, but when it comes to the integer, so it is going to get the quotient as 0 and remainder as the numerator itself. So the denominator should be lie in between something like 1 and 7, nothing but 2, 3, 4, 5 and 6, and the entire value is not equal to 0. If I am dividing by 2, the remainder is not equal to 0, then dividing by 3 and the remainder is not equal to 0, and dividing by 4 and the remainder is not equal to 0, dividing by 5 and the remainder is not equal to 0, and dividing by 6 and the remainder is not equal to 0, then you can say that so the n value is prime number. So what is the n value here? Nothing but 7. So this particular 7 is prime number. Okay, suppose if I want to find out 11 is the prime number or not. So you need to divide it by something like 2, 3, 4, 5, 6, 7, 8, 9, 10. In between 1 and 10. Then we can say that this particular 11 is a prime number. Now what is happening? I just want to check 12 is a prime number or not. 12 is getting divisible by 2. Yes. So it is not a prime number. Let me say 121. So 121 is getting divisible by 2. No. Divisible by 3. No. 4. No. 5. No. 6. No. 7. No. 8. No. 9. No. 10. No. 11. Yes. So it is getting divisible. So it is not a prime number. So if a number is getting divisible by any of the number for one single time, I mean by one number also, nothing but that particular number is not a prime number. So prime number is a number that has to be getting divisible by either 1 or by, either 1 and itself, not by any other numbers. Okay, so let us see how you are going to implement. Suppose if I am entering a value called 7, so I am storing this particular value in 7. So what is happening when it comes to the 7? I will be taking one I variable which is iterating the value starting from 2, 3, 4, 5, 6 and 7. Nothing 2, 3, 4, 5, 6. Nothing but less than 7. Nothing but I value should be greater than 1 and I value should be less than 7 within this particular range. Then what is happening? You can check while. So initially what is happening? I will initialize I value to 2. So while I is less than this particular n value. So what is the n value? Nothing but 7. I is less than 7. Nothing but 2, 3, 4, 5, 6 will be getting iterated. So I value we are incrementing. So within this particular while, what you are doing? We are checking something like if I percentile 2. So I value, n percentile I. So n value is 7, I value is 2. 7 divided by 2 is equals to 0. No, it is not equal to 0. So then it is not a prime number. Else, if it is, so I just try to change this particular thing. If it is not equals to 0, then you can say here prime number. If it is equals to 0, then you can say over here something like not a prime number. Like this I can write the code. So if you are having a value which are getting accepted from the runtime and the value has to be checked something like greater than, it is not equal to, it should be greater than 1 and it should be less than the value that you have entered. 7 is entered from n. So starting from 2, 3, 4, 5, 6. So 2 is less than 7. Yes. 7 percentile 2 is not equal to 0. Yes. So prime number. Then what is happening? I value is getting incremented. I value incremented to 3. 3 is less than 7. Yes. 7 divided by 3 is not equal to 0. Yes. Prime number. And incremented to 4. 4 is less than 7. Yes. 7 percentile 4 is not equal to 0. Yes. So we can say prime number and I value is getting incremented. Now what is happening? 5 is less than 7, yes. 7 percentile 5 is not equal to 0, then you can say prime number. Then it is incremented to 6. 6 is less than 7, yes. 7 percentile 6 is not equal to 0, yes. Then you can say prime number. Then I value is incremented to 7. 7 is less than 7, no. Condition is false, so cursor is getting out of this particular loop. So let us see how we are going to implement this particular prime number. So first of all, did I save the previous program? Yes, I have saved the previous program. Now let us implement this particular prime number code. So what I'll do, I'll just say something like int n for accepting the value from the runtime, I for iterating the value. So let us iterate. So then followed by we will be adding the couple of variables according to the necessary. So I don't want to add right now. So wherever the variable is required at that particular location, we will declare a variable. So what I'll do, let me say something like printf asking the user to enter a number. So let me say scanf accept the value, say %d comma ampersand n. Then what is happening, let me say protest giving a line gap. So what I'll do, I is equals to 2, starting from 2, let me say while I is less than n. So if I is less than n, so initially what I'll do, I'll display only the I value. So printf, so let me say I equals to %d, move the cursor to the next line, comma I, then say I plus plus. With this you will be knowing that what are the value I have entered. So in that case what is happening, the I value is getting displayed from 2 to till that particular number. So if I'm saying 7, 2, 3, 4, 5, 6. If I'm saying something like 5, 2, 3, 4. If I'm saying something like 11, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let me remove this particular code. Now what we need to do, we need to check whether the value is getting divisible by I value or not. So if n percentile I is not equals to 0, if it is not getting divisible by I value, so what I need to do, just let me say put as of prime number. Otherwise what I'll do else, simply say something like put as not a prime number. So save it. Now I value has to be getting incremented every time. Let me say I plus plus. Now what is happening, compile the code and run the code. Let me say something like my value is 2. Now in that case 2 is less than 2, here the condition is getting false. So in that case what is happening, you can say, we'll discuss about this particular part later. So let me say something like 3. So 3 is a prime number. So I equals to 2. So 2 is less than 3, yes. 3 percentile I is not equal to 0, yes. It is displaying prime number. Now let me say 4. Now what is happening, it is displaying not a prime number and prime number. So 2 is less than 4, yes. So 4 divided by 2 is not equal to 0. No, it is equals to 0. It is displaying not a prime. Then I value is getting incremented to 3. So 3 is less than 4. Yes. 4 percentile 3 is not equal to 0. Yes. It is going to display prime number. Now I value is getting incremented to 5. So 5 less than 4? No. Now in that case what is happening? Let me compile the code and run the code. Let me say 7. Now 7 is not getting divisible by 2, 3, 4, 5 and 6. So in that case it is displaying prime number for these many number of times. Why? So as I am dividing this particular 7 by 2, so in that case what is happening? It is saying prime number. Dividing 7 by 3, prime number. Dividing 7 by 4, prime number. Dividing 7 by 5, prime number. Dividing 7 by 6, it is saying prime number. Similarly, whenever I am saying something like 9, let me enter 9. So 9 is getting divisible by 2? No. So it is prime number. 9 is getting divisible by 3? Yes. It is saying not a prime number. 9 is getting divisible by 4, 5, 6, 7 and 8? No. So similarly, let me go with 121. So 121, what is happening? 121 is getting divisible by 2? No. 3, no. 4, no. 5, no. 6, 7, 8, 9, 10. It is getting divisible by 11. But once again, it is checking for 12, 13, 14, till 120 times. Now in that case what is happening, once it is saying it is not a prime number, what I want to do, I just want to stop the execution. I don't want to continue. Something like compile the code and run the code. So let me say 9. 9 is getting divisible by 2. No. 9 is getting divisible by 3. Yes. So stop the execution. No need to check for divisible by 4, 5, 6, 7 and 8. So in that case what I'll do, we'll go with break that we have. So break is a keyword which is used for terminating the execution of this particular loop, or we have already learned the break keyword which is used to terminate the switch case statement. So in that case, what is happening? When it is not a prime number, stop the execution. Now save the program, compile it and run it. Now what I'll do, I'll say 9. 9 is getting divisible by 2. No, so it is a prime number. 9 is getting divisible by 3. Yes, so it is not a prime number. Stop the execution. So whenever a value is getting divisible by any of the other value, let me say 121. Yes, it is getting stopped when it is getting divisible by 11. 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Okay, so we are able to achieve one single task, nothing but whenever it is getting divisible by any of the other number, so simply we are stopping the execution of the loop. But what is happening if a number is getting, let me say prime number, now prime number is getting divisible by 2, 3, 4, 5 and 6, no. So multiple times it is displaying prime number. Now do we require to display it for multiple number of times? No, it should be displaying for only one single time. So in that case, what is happening? Either it should be displaying prime number or it should be displaying not a prime. So for that, let me take a variable called k, which is initialized with 0 by default. Okay, now what I'll do, instead of displaying the prime number for 5 times, what I'll do, I'll just comment this particular code. I'll say k is equals to 1. So when this particular k value is getting initialized with 1, when the value is not getting divisible by any of the other value. So something like, if I'm saying 7 divisible by 2 is not equal to 0, k value 1. 7 divisible by 3 is not equal to 0, yes, k value 1. 7 divisible by 3 is not equal to 0, yes, k value 1. 7 divisible by 4 is not equal to 0, yes, k value 1. 7 divisible by 5 is not equal to 0, yes, k value 1. 7 divisible by 6 is not equal to 0, yes, k value 1. So in that case, once I get out of this particular thing, if k value is equals to 1, so what I can do, just say put as, I'll say something like prime number. Prime number. Save it. Now compile the code and run the code. Now check it out. Let me enter 7. How many times? 1 time. Let me enter, we know 3 is a prime number. How many times? 1 time. Let me enter 13 is a prime number. How many times? 1 time. But let me enter 11 is a prime number. How many times? 1 time. So let me enter something like 10. So what is happening? It is saying not a prime number. Stop the execution because 10 is getting divisible by 2. Now what about, let me say something like 9. 9 is getting divisible by 2? No. So k value will be initialized to 1 and once in the next iteration 9 is getting divisible by 3. So 9 is getting divisible by 3. Yes. So it is what is happening? It is displaying not a prime number. After getting, then we are saying break. After getting out of this particular block, as k value is initialized to 1, it is even displaying not a prime number. Now in that case, what is happening? Instead of displaying not a prime number, you just say k value is equals to 2 and stop the execution. So when k value is getting 2, we are stopping the execution. So you can say after that, else if k value is equals to 2 as, then you can say put as not a prime number. Save it. Now compile the code and run the code. Now no matter what are the value, let me say 121, not a prime number, displaying it for 1 time. So let me say something like 9 9s are 81. What is happening? It is also displaying not a prime number for 1 time. So let me say something like 11. So 11 is a prime number. So like that, what is happening? We are able to display the message in for 1 single time. What about 3? Prime number. What about 2? It is a even prime. So what about 1? Neither prime nor composite. Let me say 0. Enter a positive number. Let me say something like -5, enter a positive number. I think you got to know what we need to do. So in that case, what is happening? If n value is equals to 1. So if n value is equals to 1, just say put as, so neither prime nor composite number. Then else if n value is equals to 2, then what is happening? Put as or print as, what you are saying? Even prime number. Then else if n value is greater than 2 or greater than or equals to 3. Starting from 3. So in that case, what is happening? You can write this particular code. Now, let me provide this particular thing within the same block. So if, and we know that if you are having only one single statement, no need to provide this particular block. Now finally you are saying else, nothing but other than 1, 2, 3, either it may be 0 or negative value. So you are saying else, so let me say put as, please enter a positive number. Save it. Now compile the code and run the code. Say 5, prime number. Say 4, not a prime. Say 3, prime number. Say 2, even prime number. Say 1, neither prime nor composite. Say 0, enter a positive number. Say minus 6, enter a positive number. So this is how we are implementing something like prime number code using while loop. So in our current session, right now we have discussed about how to implement the code for identifying or printing first n even or odd numbers, where n value is 10. So 1 to 10 even numbers and odd numbers. And we have generated the Fibonacci series and we have find out the entered number is either prime number or not. Okay, thank you.